Ron, where are you? Ron St. Martin over there. This presentation is dedicated to you. You're welcome. Here we go. Okay. On my trip across Canada last summer, I do what most people do in airplanes is spot the crater. And tonight I'm going to talk to you about the St. Martin crater in Manitoba. And right now, let's see. Whoops. There we go. Oh, separate one. Yeah. So it is kind of an invisible crater, but it's kind of exciting. There we go. Now, we had this mixed up. That's why I'm getting my bearings here. Okay, where'd my airplane go? Whoops. Did it work? How come it's not working?
What are you looking for?
There should be something coming across there. Maybe it won't work. Anyway, I introduced my talks about my craters. With this picture, I usually say that I flew to Puerto Rico to investigate a crater, only to find that somebody built a radio telescope in it. And it was a good trip. So anyway, St. Martin, it is right there, in Manitoba. It is about 40 kilometers across, and to take a look at the relative sizes of it, St. Martin there, and if you see that circle in Quebec, the Manicouagan crater, it's pretty similar in size to that. It's the same size as Charlevoix that Ron and I trekked through, and it's a little bit bigger than the Clearwater lakes, and some of the biggest craters on the planet. It's very comparable. So getting closer, Lake Winnipeg, Lake Manitoba, and just over here, Dauphin Lake, just to get your bearings correctly here. The way they actually discovered that this is a crater is in the middle of the crater is a little town called Gypsum. And they had a gypsum mine there. And scientists thought, well, it's a little bit kind of interesting, the minerals coming out of this. They analyzed it and they found what's called planar deformation features. And this is a feature in quartz or feldspar that if you look at the whoops, wrong button here. Here we go. The linear striations inside this is about less than a millimeter across. And this kind of effect only occurs during a large impact of a bolide hitting the planet at 12 plus kilometers per second, or a nuclear explosion. Well, we dated this structure at over around 219 million years, so we pretty well eliminated a nuclear explosion. So we...
You can check the UFO museum.
Oh yeah, there's that, Bob. We have to check that out.
It's a research center.
Yeah, oh yeah, of course. That makes it real. So, as I mentioned, about 219 million years ago, right in this area. Now, there's a lot of interesting geological effects happening here. It was right after the major extinction at 250 million years, where about over 90% of the life on this planet was eliminated. The Siberian traps is the main culprit for that extinction right now, but it's still up in the air. But just keep in mind, I'm going to get into it a little bit later, there is a lot of things happen between these two extinction areas here. Just to give you an example, large reptiles and dinosaurs, their species had split, and of course the dinosaurs after this extinction right here, they started to be the dominant life on this planet. There's no mammals for another 50 million years. There's no flowers, and there's no hardwood forests. So give you an idea of what's going on this planet when this happened. So, as I mentioned, most people when they fly across the country, we play spot the crater, don't we? And this picture I took, the St. Martin crater is right about here. I showed you on the map Lake Dauphin, just to give you some perspective. The Saskatchewan border is right over there. So I was pretty excited to find out that we're right over this meteorite crater. And of course, everybody in the airplane shared my excitement. I dodged a few magazines coming at me, but anyway. It was actually between this crater and where we landed in Ottawa, there were 9 meteorite craters. And of course, I pointed them out to everybody. And I think we're all happy to land in Ottawa.
In one piece.
In one piece. Actually, I was still in one piece, so nobody bought me a drink. So anyway, in my airplane, I got a little bit closer to it. And this here is ground zero on the St. Martin crater. And essentially, you can see there's no surface expression of this crater. So, why does Chuck say this is a very exciting place to be? Well, first of all, the crater is buried. It's under over 100 meters of glacial drift, of course, from the last ice ages, and Jurassic sediment. Now, when the bolite happened, there was a lot of geology happening at the same time, and the crater was almost immediately buried by the sediments from the Jurassic period. So what we've got underneath this 100 meters is one of the most pristine craters on this planet, compared to anything on the moon, because it's been buried and the geology of the crater itself hasn't been touched since the impact. So inside there's a very definite central peak, well defined, with an annular trough, the annular trough right after the central peak. Now, if you remember that picture of the Manicouagan crater I showed you with the circle, well, that's the same as the trough here. And of course, we had a very good defined crater rim as well. Drilling through here was very, very fruitful for research and so on for the breccia and, of course, the planar deformation features, which did define what the crater was. But unfortunately for the people in Gypsum, the groundwater itself was contaminated by fluorides and so on, and the water itself was full of calcium sulfate, aka gypsum, and that's why the town was named after that, I suppose. But there was a gypsum mine there for a long period of time, right at ground zero on the central peak. But that's not all that's happening on that crater. Dr. Spray, he's another guy that's kind of interested in craters like me. He's actually a PhD in it. And he has a very interesting hypothesis. Now, I showed you the time span this happened at. Well, within that time span, the Red Wing in Minnesota, of course, St. Martin, Manicouagan, one over here in France that I can't pronounce for the life of me, and the one in the Ukraine here, Obolin. They all happened at the same relative time. Now, the dating methods that we have here are plus or minus a couple of million years because of the radioactive decays and the contaminations and so on. So every one of these craters are within the error spikes of these dating methods. So the hypothesis here is that at this time there was what's called a meteor or a meteorite shower, large impact that created this crater chain. And looking at the geology of the planet from, 219 million years ago, this is the situation where the continents were. And a little bit better. It's almost totally in line here. So the hypothesis hasn't been proven or disproven, but it's an interesting hypothesis to say that, hey, this may have been a large heavy bombardment at 219 million years ago. One of the craters, there's St. Martin there, Manicouagan. This is the one that I mentioned with the large circle. So the size of the St. Martin crater is almost the same as the same size. And just as an aside here, Eric, the guy on the camera, we explored this crater into Memory Bay here. It's very fascinating geology. And we were actually marooned on that island for a little while. If you look at the way the circle is here, well, the wind, when we took off, we had our campsite right in here. And we took off one morning to get across to where the car was. And it started off pretty calm that morning, didn't it?
Yeah, it was nice.
But the wind coming from the west, we were in the lee here, veered around to the north, coming straight down this pipe. And the wind, basically the waves are almost 6 or 7 feet high. So here we were, two guys, we're not light guys, a canoe full of rocks. So Eric very wisely said, Chuck, I think we better bail out. So we did. We spent most of the day, actually almost 24 hours on that island. So we looked at our food and we thought, well, we have 5 days. I think we could survive. But fortunately, the wind did die enough for us to get across. Interesting adventure. Anyway, more adventures in Craterland for Chuck. So anyway, this is the...
on another occasion.
Yeah, well, actually, yes, we should. We should. We have excellent videos on that. This is the continents today, and of course, the craters are not in line anymore. But as we said, that the dates of these craters are pretty close to say that this is a possibility. So research is ongoing for this. So the final point I'm going to make, there's a large crater that was discovered in Chesapeake, the same kind of thing as St. Martin's. It's buried. It's under a lot of glacial drift and so on, and the way they discovered it was from drilling and finding planar deformation features and breccias and so on. But what I want to show you about the Chesapeake crater, it is almost the same as the St. Martin. If we look at, see the circles I just drew there? The York and James rivers, right on the crater rim. And the hypothesis is, and this has been published, that look at the 90-degree diversion of this river and the same of the York up here, right on the crater rim. And the scientific theory on this is that the breccia inside the crater had slumped enough that there was a differential in the density of the various land densities. So they cause these great diversions. Well, this is a published theory about the Chesapeake, and there's a similar thing in the St. Martin that nobody has published or talked about. If you look at the Dauphin River here, it has the same effect. Now, if you look at a meander, that's a typical meander of a river. It's almost a sine wave, but this is not a meander. This is a definite diversion. So if you look at the fact that the river has diverged right on the crater rim, very similar to the Chesapeake. Here, you look at the James and the York rivers here.
Which way does that river flow? North?
It goes from the St. Martin Lake into Lake Winnipeg that's over here. Of course, the terrain around this area is very, very flat, so hence the floods. And the drainage is from south to north. Of course, it thaws the last up here, so the water comes up and finds the ice, so of course it backs up and floods everybody. So this is the reason for the floods there. But to my knowledge, there has not been any explanation for this large diversion. So Chuck and his infinite wisdom here thought, well, I'll call this Chuck's hypothesis. And I've published it on the website, and we'll see where it goes from here. But anyway, this is a picture of the diversion. This is at the northeast part of the crater itself. And it's not a meander. It's a deliberate diversion of the river direction. Yeah, and you would think, you usually find this in a mountain or something, that, between the mountains and so on, the various geological faults cause the river to change directions very drastically. But the land here is extremely flat, so who knows? And of course, the Dauphin River goes further out, following the rim. This is the rim of the crater here, and follows the river right out to the Lake Winnipeg out here. So, on that note, that's it, and thank you for your attention. Sure. Any question? Anybody with crater spotting?
The 5 craters that you showed up on the earlier
Yeah.
Latitude map,
Yeah.
is there any evidence, I mean, aside from the positioning and the approximate times, is there any evidence of similar composition, that they might have come from one larger broken up body or anything like that?
That's a good question. The question is that is there any composition of the bolite itself that is an indicator of what kind of meteorite hit there? And the answer is no, not yet. There hasn't been any confirmation of that. That's why we're still in a nebulous theory about this. The only, I'd say, a confirmation of his hypothesis is the fact that it's in line and they're all on the same date. So aside from that, we really don't have anything else. As we get into more and more research, of course, the one in the Ukraine hasn't been studied at all, to my knowledge, or very much. This one here is extremely eroded. This one here, West Wing, it's buried. It's similar to St. Martin. It's very, very buried. And the Manicouagan, any sign of the bolite itself has been washed away. Over the crater itself, you're looking at maybe about 2 kilometers of erosion. So the only way you'd find that is the impact melt itself. You may find some kind of indicator that the bolite has influenced the melt. It happened in Brent, but not to these craters, to my knowledge. Mm-hmm. That was a long answer to a short question. Okay, thank you very much. Oh, there's one.
I was just going to say, Chuck, that radial drainage pattern is, typically associated with the sedimentary dome. I mean, really, it's the same phenomenon kind of.
Yeah. So what? I guess the question is then, what influenced that sedimentary dome? And whoops, I'm going the wrong way.
Well, with the sedimentary dome, it's just uplift. You have igneous intrusion, but here you've had an impact, so you've got a similar thing where you're a crater rim.
Yeah.
It will be acting, the same way as sort of some uplift.
Mm-hmm. Yeah, I'd like more opinions from a geologist, but we definitely have a change in density of the bedrock underneath it. There's a lot of breccia here, of course, with the gypsum and so on, the mine. Then there's nothing like of any breccia type of deposits outside. So there is a density difference, and the hypothesis is that these rivers were changed because of that difference. So yeah, that dome effect is a effect, and of course we had that central peak is right in the middle. Where are we here? Right there. So you're looking at the diversion of the river right on the crater rim. So within this, of course, it's you got the slumping and so on, but the glacial fill would make it all level, but the erosion rate or so on would be different. That's my amateur answer to that. Okay. Oh, there's one in the back there.
Chuck, as crater chains go, when we look at other bodies in the solar system, even when the continents were closer together, don't you find those sites to be pretty widely dispersed?
Yeah. Yeah, exactly. It's not exactly in line precisely. Some of the crater chains we saw on one of the moons on Jupiter, I think, I can't remember exactly, but there's one that the chains are right in line. And this is not totally in line. That's the opposite argument to the crater chain hypothesis. So, yeah.
Or the Shoemaker Levy.
Yeah, the Shoemaker Levy, of course, was bang, 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 bang. Yeah. Okay. Thank you very much.